Hi students, in this video we are going to discuss about system testing and debugging. Ultimately, software is incorporated with other system elements, example hardware, people, information, and a series of system integration and validation tests are conducted. These tests fall outside the scope of software process and are not conducted solely by software engineers. However, steps taken during software design and testing can greatly improve the probability of successful software integration in the larger system. A classic system testing problem is finger pointing. This occurs when an error is uncovered and the developers of different system elements blame each other for the problem. Rather than indulging in such nonsense, use it expect potential interfacing problem, design error handling path that test all information coming from other element of the system, conduct a series of tests that simulate bad data or other potential errors at the software interface, record the result of test to use as evidence if finger pointing does occurs, and participate in planning and design of system tests to ensure that software is adequately tested. System testing is actually a series of different tests whose primary purpose is to fully exercise the computer based system. Although each test has different purpose, all work to verify the system element have been properly integrated and perform allocated function. In this video that follow, we discuss the types of system tests that are worthwhile for software based system. Many computer based systems must recover from fault and reassuming processing with little or no downtime. In some cases, a system must be fault tolerant, that is, processing fault must not cause overall system function to cease. In other cases, a system failure must be corrected within a specified period of time or severe economic damage will occur. So, recovery testing is a system test that forces the software to fail in variety of ways and verify that recovery is properly performed. If recovery is automatic, performed by the system itself, reinitialization, checking point mechanism, data recovery and restart are evaluated for correctness. If recovery requires human intervention, the mean time to repair is evaluated to determine whether it is within acceptable limits. Any computer based system manages sensitive information or causes action that can improperly harm individual is a target for improper or illegal penetration. Penetration spans a broad range of activities. Hackers who attempt to penetrate system for sport, disgruntled employees who attempt to penetrate for revenge, dishonest individual who attempt to penetrate for illicit personal gain. So, security testing attempt to verify protection mechanism built into a system will in fact protect it from improper penetration. The system security must of course be tested for invulnerability from frontal attack, but must also be tested for invulnerability from flank or rear attack. Earlier software testing steps resulted in thorough evaluation of normal program function and performance. Stress tests are designed to confront programs with abnormal situations. In essence, the test who perform stress testing ask how high can we crank this up before it fails. Stress testing executes a system in a manner that demands resource in abnormal quantity, frequency or volume. For example, special tests may be designed that generate 10 interrupts per second when 1 or 2 is the average rate. Input data rates may be increased by an order of magnitude to determine how input functions will respond. Test cases that require maximum memory or other resources are executed. Test case that may cause thrashing in a virtual operating system or design. Test case that may cause excessive hunting for disk resident data are created. Essentially, the tester attempt to break the program. For real-time and embedded system, software that provide required function but does not conform to performance requirement is unacceptable. Performance testing is designed to test the runtime performance of software within the context of an integrated system. Performance testing occurs throughout all steps in testing process. Performance tests are often coupled with stress testing and usually require both hardware and software instrumentation. That is, it is often necessary to measure resource utilization in an exacting fashion. In many cases, software executes on variety of platforms and under more than one operating system environment. Deployment testing, sometimes called configuration testing, exercises the software in each environment in which it is to operate. In addition, deployment testing examines all installation procedure and specialized installation software that will be used by the customer and all documentation that will be used to introduce the software to end users. An example, consider the internet accessible version of Safe Home software that would allow a customer to monitor the security system from remote locations. The Safe Home web app must be tested using all web browsers that are likely to be encountered. Software testing is a process that can be systematically planned and specified. Test case design can be conducted, a strategy can be defined, and the results can be evaluated against prescribed expectation. Debugging occurs as a consequence of successful testing, that is, when a test case uncovers an error. Debugging is the process that results in the removal of the error. Although debugging can and should be an orderly process, it is still very much an art. Debugging is not testing but often occurs as a consequence of testing. Referring to this figure, the debugging process begins with the execution of test case. Results are assessed and lack of correspondence between the expected and actual performance is encountered. In many cases, the non-corresponding data are a symptom of underlying cause as yet hidden. The debugging process attempts to match symptom with the cause, thereby leading to error correction. The debugging process will usually have one of two outcomes. The cause will be found and corrected, the cause will not be found. In the latter case, the person performing debugging may suspect a cause, design a test case to help validate that suspicion and work toward error correction in an iterative fashion. Why is debugging is so difficult? In all likelihood, human psychology has more to do with an answer than software technology. However, a few characteristics of bug provide some clues. The symptom and the cause may be geographically remote, that is, the symptom may appear in the one part of the program while the cause may actually be located at a site that is far removed. Highly coupled components exacerbate this situation. The symptoms may disappear temporarily when another error is corrected. The symptoms may actually be caused by non-errors. The symptoms may be caused by human error that is not easily traced. The symptoms may result of timing problem rather than processing problem. It may be difficult to accurately reproduce input conditions. The symptom may intermittent, that is particularly common in embedded systems, then couple hardware and software inextricably. The symptoms may be due to causes that are distributed across a number of tasks running on different processors. During debugging, we will encounter errors that range from mildly annoying, example incorrect output form, to catastrophic, that is a system fail causing serious economic or physical damage. As a consequence of error increase, the amount of pressure to find the cause also increases. Often, pressure forces some software developer to fix one error and at the same time introduce two more. In general, three debugging strategies have been proposed: brute force, backtracking, and cause elimination. Each of these strategies can be conducted manually, but modern debugging tools can make the process much more effective. The brute force category of debugging is probably the most common and least efficient method for isolating the cause of software error. You apply brute force debugging method when all else fails. Using a let the computer find the error philosophy, memory dumps are taken, runtime traces are invoked, and the program is loaded with output statements. You hope that somewhere in the morass of the information that is produced, we will find a clue that can lead to the cause of an error. Although the mass of information produced may ultimately lead to success, it more frequently leads to wasted effort and time. Backward path may become unmanageably large. The third approach to debugging is cause elimination, is manifested by induction or deduction, and introduce the concept of binary partitioning. Data related to the error occurrence are organized to isolate potential causes. A cause hypothesis is devised and the aforementioned data are used to prove or disprove the hypothesis. Alternatively, a list of all possible causes is developed and tested are conducted to eliminate each. If initial tests indicate that a particular cause hypothesis so promise, data are refined in an attempt to isolate the bug. Once a bug has been found, it must be corrected, but as we have already noted, the correction of bug can introduce other errors and therefore do more harm than good. Let these three simple questions that should be asked before making the correction that remove the cause of a bug. Is the cause of bug reproduced in another part of the program? In many situations, a program defect is caused by erroneous pattern of logic that may be reproduced elsewhere. Explicit consideration of logical pattern may result in discovery of other errors. What next bug might be introduced by the fix I am about to make? Before the correction is made, the source code should be evaluated to assess coupling of logic and data structures. If the correction is to be made in highly coupled section of the program, special care must be taken when any change is made. What could we have done to prevent this bug in first place? The question is the first step towards establishing a statistical software quality assurance approach. If you correct the process as well as product, the bug will be removed from the current program and may be eliminated from all future programs. Thank you.